we go. We got the great state of Nevada right there, and I know a lot of people think Nevada, they think Las Vegas and blah blah blah, but I'm still thinking aliens. Area 51 is right here in the desert somewhere where all these, the #1 UFO tour site in the world. Area 51, a bunch of aliens. Christ, let me slide this over. I'm like, oh my goodness, what is that? It's Alien Kelly. Can you believe that? Maybe one of the aliens you would get to see if you go visit that. So if you're ever in Nevada, check it out. Somewhere in this desert out here is supposed to be a bunch of aliens. I gotta get this picture of Alien Kelly out of here. It's creepy. It's really creeping me out. Let's get rid of that. Why'd I pick Nevada? Well, Nevada happens to look like a trapezoid. We're still doing Area 51. Yeah, rough connection there. Tied all together. We got trapezoids, kites, and rhombus. You can say rhombi for plural or rhombuses. Rhombuses? I like rhombi better though. So let's take a look at this. So I picked Nevada because it looks like a trapezoid. So let me bring this to the front, and what happens here? I can slide this over. Check that out. It's like a perfect trapezoid. So I want to know the area of Nevada. I've always wondered the area of Nevada. So let me take this, and maybe it's not the easiest to look at that. So let's copy one of these, and maybe we can spin it around here, just so sometimes people have a better time looking at it like this. So either way is the same difference. I got this trapezoid here, and I'm going to shrink it down, but I'm going to label the parts of it. So the one side over there was 309. Let's go ahead and put that on there for us. So this is 309. Up top was the 205, and on bottom was the 511. So if you want to spin it around, but it doesn't matter. To find the area of a trapezoid, we need a formula. The formula is going to be, and it's pretty cool. If we have time, we'll prove it. 1/2 base 1 plus base 2 times the height. So we've got 1/2 base 1 plus base 2 times the height. So in this case, this is base 1, this is base 2, and it doesn't matter what you call, if you want the smaller one, B1, B2, it doesn't matter, and that's the height of the trapezoid. So really, if I want to solve this, I'm just going to take the area equals 1/2 base 1 is 205 plus 511 times it by the height, in this case 309. And again, this is just a bunch of calculator, really. I'm going to put this in. Just make sure that you add your bases first. So you can, what I usually do is I just go ahead and add them together. 205 plus 511. Put those together, and I get the 716. Where is that? So I've got the 716. And if you want to do all in one step in the calculator, you can, but this is 716 times 309. Now let's just multiply that all together. We've got 0.5 times 716 times 309. What's that going to give me? The area of Nevada in miles is 110,000 miles. So pretty awesome. So 110, I think it was 622, and this is square miles. So if you're ever curious what the square mileage of Nevada is, now we know. Fantastic. Moving on. So, area of trapezoid. I've got 2 more here to try, and then we'll move on to kites and rhombus. Find the area of this one. Well, I threw a lot more information, but again, here is, we're looking for, in a trapezoid, one of them is the base. Remember, they're parallel. Trapezoids are parallel to each other. The other one is B2. And then somewhere along here, we're going to have to give you the height. So those are our parts. So 1/2 B1 plus B2 times the height. So let's do a little plug and chug here. Put these numbers in. I know there's one base. There's another base. So I'm going to go 1/2 8 plus 17 times, whoa, I didn't give you the height. No, you didn't, Mr. Brust. So you got to figure it out. And what am I doing? Well, we've got a little triangle here. So let's change colors. If you notice, this is a right triangle. Since this is a right triangle, I can do a trig function. So off to the side somewhere, I got to say, okay, this is opposite over hypotenuse. So a little bit more work on this one. The sine of 42 equals opposite over hypotenuse. I like solving these, though. This is nice. All you got to do is times both sides by 11 to solve this one. So times this by 11. So really you get 11 sine 42 equals h. And I'm going to need a little help for the calculator. What is the 11 sine of 42? Again, make sure you're in degrees. You'll get weird answer if you're in radians. Double check your mode. I get 7.36. So we'll round to 2 decimals. The height is 7.36. So all that work was just to find the height. Now I can go back up here and say, oh yeah, the height is 7.36. And I'm good to go. If you want to simplify a little bit on your own, you're doing 1/2. 8 and 17 is 25. But at some point, I'm going to have to go calculator, get these decimals. So let's do it. I'm going to go 0.5 is my half, times 25, times 7.36, and I get 92. So that is my answer, 92. What am I in? Square meters. So that would be the area of this trapezoid. Very nice. How about the other side here? Find the height of this trapezoid. So here I'm giving you the actual area. The area is 51.5. You have to find the height. So now check this out. One of the bases is 3.5. The other base is 11.1. And what is the actual height? You got to solve for h. I like this. So we got to do a little bit of work here. But it's not too bad. If we can simplify a little bit. This is 51.1. Let's add our parentheses together. 3.5 and 11.1 is what? 14.6? And really I'm taking half of that. So 51.1 equals half of that. You can go in your calculator, but half of that is 7.3. And now I can find h. How do I find h? I'm going to divide both sides by 7.3. Fantastic. So h is going to equal, let's finish this out, 51.1 divided by 7.3. And I get 7. So that one worked out friendly. And this is what? This is 7 centimeters is the height. So I actually went and found the height this time. So that may happen. Sometimes you're going to find the area. Sometimes I give you the area. You got to work backwards. So that's trapezoids. That's really it in a nutshell. If you can do those two problems, you'll be good on the mastery check for that. How about kites and rhombuses, or rhombi? I like rhombi. There's a formula for it, but we really got to know our stuff. I'll give you the formula. The formula is 1/2 diagonal 1 times diagonal 2. But I really got to make sure you're okay with all the properties of kites. So this was like back in chapter 5. So what happens on kites? Remember, this is congruent to this. So that's going to be important. Also, these up here are congruent if you need that, and these are congruent here and here. And what's really going to help us is it makes a right angle all through all these. So we may need that if we have those special right triangles and whatnot. So we got to know that type of stuff. How about a rhombus? Remember, the diagonals bisect each other, so that's really huge for us. And then the outside is all the same. These are all congruent in a rhombus. A lot of squiggly marks. And again, this makes all that. So if I give you something in a rhombus, like maybe I won't give you a ton of information. Maybe I give you this is 8 and this is 10. What can you do? You can say 8 and 8 and 10 and 10. Now I have, because they're congruent, 8 and 8, 10 and 10. So you can do 1/2. What's your first diagonal? Well, here's a diagonal. Is 16 times, I'll change colors here. What's my second diagonal? Is this one. 10 and 10 is 20. So you got to add those diagonals together. Then it's just a matter of multiplying it out. Half of 16 is 8 times that is 160. So again, I don't know what this is. Let's just say it's units. I just kind of made this one up, units squared. So that's going to be important. There's our different diagonals. Again, here's one diagonal in this one. That would be like diagonal 1. It doesn't matter what you call which. That would be like diagonal 2. So we're kind of filling those in here. D1, and I'll change colors just so it looks pretty. Oh wait, I should use red. D2. Those are my two diagonals. So that's the formula we're using. We're just going to cut in half, and there is our area. So have that formula. So let's do some of these. Now we got them. Let's do some of these. I kind of threw a little formula sheet at you. I'll give you these on the mastery checks, but I'm not going to name them. So I expect you know, oh yeah, parallelogram is base times height. Triangle is 1/2 base times height. Trapezoid we got as 1/2 B1. And again, I'll give this to you, but you got to recognize that's a trapezoid. And it looks crazy, so I mean, that's trapezoid. And then kites and rhombus, oh yeah, diagonals. We're thinking diagonals. So you'll have something like this, not labeled. I'll just random area formulas. You got to use what you got to use. So if I give you a rhombus, and this is a normal one, you've got to fill in your property. So I gave you, this is 20 over here, so this is also 20 over here. If that's 30 over there, this is 30. Formula says what? 1/2 diagonal 1. So what is diagonal 1? Let's do this. Let's say this is diagonal 1, so 30 and 30 is 60. And what is diagonal 2? It's this one, 20 and 20. So I kind of had to fill in those missing parts to make sure I got it. But there it is. And then multiply this out. Half of 60 is 30. 30 times 40 is 1,200. So this is 1,200 square feet. Awesome. And if you want to go calculator, just go calculator, type it in. A kite now, and do a kite. And this is a trig, I'm going to work some trig into this one. If you can't read that angle, hopefully it shows up better in your paper. That is a 31-degree angle. And why is that angle important? Well, we've got a right triangle. Again, I'm looking for the diagonal. So my ultimate goal is I need this diagonal. And if that's 20 over there, this is 20 over here. So I'm good to go there. But this one is a little bit more work. I need this whole thing. And these aren't congruent, these two different pieces here. So I got to use this top little triangle up here to solve it. So I've got this triangle right here. And if you want to redraw it, you can. I'm looking for this piece right here, x. So how do I relate these? So if you really want to, if I can make it a little bigger here, this is the 32-degree angle, x, and 20. I got to tie this all together. What trig function, since this is a right angle, ties this all together? I believe I'm looking at opposite. This is pointing at it. Opposite over adjacent. So I'm looking at tangent of 32 equals x over 20. So if you got to go back and review 7.3 and 7.4, maybe you want to check that out. But if not, hopefully trig's flown for you. To solve this, just multiply both sides by 20. So I'm really saying x is 20 tangent 32. So I'm going to say 20 tangent 32 and hit enter. I've got about, I'm going to round this up. Since the 7 makes that round up, I'll go 12.5. So I'm looking at that as 12 and a half. And if I want to label it, that's inches. But that is just this piece up here. So the 12 and a half is this piece. So now when I do the diagonals, I think we're ready for the diagonals. I can say the area is 1/2. Diagonal 1 is 20 and 20 is 40. No problem there. Diagonal 2 is this 12 and a half and 26. So I got to add them together. So I get 38 and a half. So you have to combine this whole thing together. So 26 plus 12.5. That's how we get the other diagonal. So that would be diagonal 2. Awesome. Very good. Now it's just a matter, and if you want to go calculate, let's just do this calculator. 0.5 times 40 times 38.5. Boom. Done and done. We're looking at 770. So this is 770 inches square. Fantastic. There is the area of that. So we're going to work some trig in there. I love it. Keep that fresh. Also maybe some Pythagorean theorem. So we've got some rhombus going on here. It is kind of hard to read, but I believe the 8 goes to this one here. So if this is 8, this is also 8 over here. You know, if that's 10, this is also 10, and it's rhombus are all 10. I don't know if that helps us or not, but I could fill those in. And I know those are all right angles. So really, I need this other diagonal. So if you look at just this chunk of it, I've got 8, I've got 10. Can you find this missing side? Sure, it's Pythagorean theorem. So we'll do the two short sides. So we'll go x squared plus 8 squared equals what? 10 squared? And simplify this a little bit, and maybe you recognize this. I think this is also one of our Pythagorean triples. When you square up, subtract 64 from both sides. And what's that give us? 36. So if x squared equals that, let's square root both sides, and what do we get? We get x equals 6. So this missing side here is 6. If that's 6 up there, this is 6 down there, because they are congruent. So we got to know all the properties. Now we can finally, that's just to get us warmed up to do the area formula, so a little bit work before. Diagonal 1, diagonal 2. Let's plug them in. So we've got half of, what's diagonal 1? Let's do the blue ones. I'll do it in blue. So we got 8 and 8 is 16. And diagonal 2 is 6 and 6. So add them together, you get 12. So it's the whole diagonal there. And just multiply this out. We are going to end up with 1/2 of 16 is 8. 8 times that is 96, I believe. So we've got 96 inches squared. Da, 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 da. Worst looking 9 I've ever made. Excellent. Very good. Very good. And I think we've got one more here. This is the finale already. I threw a little 30, 60, 90. Again, if you want to bypass this and go straight to trig, I'm cool with that and get the decimal answer. I'm going to go ahead and do it with to show you how to get the exact answer, but we're not going to require this. So I need a lot of information. I'm missing 2 parts. I'm missing x and y. I need both of these. Is this enough? Sure. Well, this is a 30, 60, 90 triangle. So if it's a 30, 60, 90, there's my 1, my 2, and my radical 3. And so if I do my proportions, I can say, well, 10 is to 2. 10 matches 2 as y is to 1. So really I don't have to cross multiply. That just means what? Y equals 5. So I know y is 5, so I'm going to go ahead and fill that in. That's 5. And maybe you know the pattern. Really the pattern is this is going to be 5 radical 3. That's kind of the shortcut. But if not, go ahead and do the same thing. 10 is to 2 as that was x. x is to radical 3. Do a little cross multiply action here. We get 2x equals 10 radical 3. And divide by 2, x equals 5 radical 3. So that is the exact value of this one here. So that's enough. That's 5 radical 3. Over here is 5 radical 3. So let's do our formula. We got area equals 1/2. One diagonal is just 5 plus 18. 5 plus 18 is 23. The other one's a bit trickier. What's 5 radical 3 plus 5 radical 3? It's like what's 5 apples plus 5 apples? It's 10 apples or 10 radical 3. And then it's a matter of multiplying all this together, which is doable. 1/2 of 10 is 5. 5 times 23 is 115. So this should be 115 radical 3 centimeters squared. So if you don't like that, you can go all decimal. You could have gone 0.5 times 23 times, what was that last one? 10 radical 3? 10 square root, remember it's right above the x squared. And if you type all that in, you get 199.19. So if you want to make this a decimal, 199.19. Either one of these is cool, whichever one you prefer. And again, if you didn't have to use the special triangles, you could have went straight trig. I could have started off with what's the sine of 30? Well, it's y over 10, and solve that. That would give me this side right here. Then I could have done the cosine of 30, and that would give me this other side. So you can win all decimals. As long as you get the right answer, I don't care. Either way is great. Fantastic. That's the whole lesson right there. We're going to end with this guy who you may get confused as an alien because of the noise he's making, but he's actually one of the best human beatbox people in the world. Good luck on the mastery check. Peace out.
One, two.